Welcome to the in-depth technical analysis video of chainsaw, troubleshooting, and diagnostics. Take a close look at the two diaphragm carburetors, currently in the mechanic's hands. This visual comparison clearly shows that the old component is severely clogged with mud and dirt. This terrible condition directly affects the air-fuel mixture ratio. A quick cut to the environmental setting reveals a rugged, mountainous terrain, along with a river and lake ecosystem. The high saturated humidity in this waterside setting is the number one enemy of the ignition system. Additionally, the rubber pump diaphragm inside the carburetor is also highly prone to aging and hardening. Wide drone shots provide a panoramic view of the operational area and mechanical equipment storage. The technical expert is heading to the worksite on a personal motorcycle across rough dirt terrain. A quick verification phone call is made to pinpoint the exact location of the chainsaw. In the field machinery maintenance process, accurately assessing the storage condition initially is absolutely essential. This helps the expert quickly analyze and isolate the root causes of leaks or secondary failures. This two-stroke chainsaw is temporarily stored on a small wooden boat floating near the water's edge. This floating storage environment is extremely damp and completely substandard for an internal combustion engine. Moisture can permeate through the intake port, left open, or oxidize the electrical contacts of the magneto. The mechanic pulls the rope to bring the boat ashore and carefully moves the equipment out of the damp area. The setup for a field diagnostic and repair station is immediately carried out with the utmost care. She prepares a heavy rock as a load-bearing support, placing the engine block on a cardboard box to isolate it from the ground. The resting surface for the machine requires absolute stability to fully absorb the recoil when pull starting. Bringing the specialized toolbox close to the workspace, the initial preliminary diagnostic process officially begins. The load testing phase involves pulling the starter cord multiple times, but there is absolutely no response from any combustion cycle. The engine block remains completely unresponsive. These clinical symptoms point to a loss of spark or a clogged fuel line. Opening the toolbox and pulling out the tool pouch, she proceeds to remove the upper cylinder cover. The motion of twisting the quick release knob is extremely decisive, instantly revealing the air filter assembly and spark plug. She directly lifts the intake air filter out. This is a crucial shield, preventing sawdust from entering the cylinder. Localized dirt accumulation around the intake valve proves that the engine has been operating under severe conditions. Grabbing a specialized T-handle spark plug wrench to loosen and remove the spark plug from the cylinder. To head. Inspecting the spark plug is a mandatory technical protocol that provides accurate data on the fuel ratio inside the combustion chamber. The camera focuses on the carbon-tipped electrode, showing a thick layer of excess fuel and oil residue causing a flooded condition. Using specialized dry paper towels, she wipes the electrode clean to completely eliminate the risk of spark short-circuiting. Reattaching the high-tension lead, she touches the spark plug body against the engine block to create a ground, then firmly pulls the starter cord to test the spark. The emitted spark is very weak or nearly non-existent. The next step immediately applies the manual technique of checking compression, sealing the spark plug hole tightly with a thumb and pull starting the engine. This method allows the mechanic to directly feel the piston ring seal. The compression force strongly blows her thumb outward, confirming that the combustion chamber's compression parameters are perfectly up to standard. She immediately reinstalls the spark plug into the combustion chamber threads after confirming the mechanical system of the piston and cylinder is still tightly sealed. The current troubleshooting focus narrows down to the fuel delivery system. The process of removing the carburetor assembly begins to unfold. She uses a flathead screwdriver to sequentially loosen the retaining bolts connecting the intake manifold flange of the combustion chamber. Taking a quick break to drink water and recharge, she prepares to dive into the detailed disassembly of the diaphragm carburetor assembly, removing the upper engine cover completely. To expand the working space, she extracts the carburetor, pulling the bolts aside using a flathead screwdriver, removing the remaining screws holding the air filter bracket. The tightening torque is quite high due to thermal expansion. The mechanic slowly loosens each metal thread, lifting the filter bracket assembly out, directly accessing the chainsaw's diaphragm carburetor. Deftly using her hands to unhook the throttle edge and pushing the choke valve off the mechanical lever, sliding the carburetor off the two mounting studs, discovering heavy dirt coating the venturi, she decides on a cleaning and maintenance plan before resorting to a brand new replacement part. A backup carburetor box is placed nearby to cross-reference the intake layout if necessary, setting up a makeshift plastic tray to hold solvent, beginning the soaking and cleaning process for the engine parts, pouring a gas-oil mixture from a plastic bottle into the tray to serve as a cleaning solution for the carbon deposits. The cleaning process requires great meticulousness, using a brush to scrub every corner of the flange, fully submerging the carburetor assembly into the gasoline solvent, dissolving the sludge and sawdust stuck in the openings. Holding the aluminum alloy block firmly, the mechanic continues using the brush to clean the microfuel filter mesh, rinsing with fresh solution to completely flush out tiny grit particles that could jam the needle valve, decisive scrubbing motions around the copper tube, the direct connection point to the intake fuel line. After cleaning, the carburetor assembly reveals the original shiny surface of the DU0069 E-cast zinc alloy, using a soft towel to soak up all excess solvent, to prevent engine flooding upon restarting, rechecking the spring tension of the throttle valve, ensuring the pivot shaft is not sticking after cleaning, clearing away the solvent tray in preparation for reassembling the old carburetor back onto the engine block. This restorative test step aims to check if surface clogging was the root cause, carefully threading the carburetor onto the two studs, reinstalling the round thermal gasket to prevent air leaks, fitting the choke lever into the correct retaining slot, ensuring the mechanical open-close stroke is perfectly smooth, hooking the steel throttle age rod into place, synchronizing the throttle rhythm with the trigger on the chainsaw handle, using a screwdriver to tighten the screws evenly on both sides, so the flange presses tightly against the cylinder intake gasket, a screwing operation that requires balanced force. If tightened unevenly, it will create a gap, allowing outside air into the combustion chamber. Placing the plastic air filter bracket onto the carburetor assembly, locking the latches securely. To complete the secondary reassembly cycle, the mechanic stands up, stepping on and holding the handle, establishing a safe stance in preparation to start the engine. Pulling the starter cord multiple times, but the machine remains perfectly silent. The hissing from the combustion chamber indicates that fuel is still not being pumped. The attempt to restore the old components has officially failed. The internal jets or pump diaphragm are completely ruined. Without hesitation, the mechanic immediately disassembles everything again, deciding on a deeper intervention by replacing the parts. The replacement parts box is opened. A carburetor that is brand new is prepared to be transplanted into the system. The part replacement and installation happen in a flash, inserting the brand new original diaphragm assembly into the intake, precisely adjusting the choke valve clearance, ensuring the ideal air-fuel mixture ratio for the two-stroke engine. The flange bolt tightening force must meet torque standards to avoid warping the thermal gasket and causing a pressure leak. Closing the air filter cover completes the maintenance phase. The chainsaw's condition is now fully ready. The technician assumes the standard pull start stance. The engine roars to life powerfully. The system operates perfectly. The scream of the engine at high RPMs confirms that replacing the carburetor was absolutely the correct move. The frame abruptly shifts to a new diagnostic case. The target this time is the transmission system of a standard motorcycle. Using a specialized cordless impact wrench, quickly removing the screws securing the chain guard. Removing the chain guard cover reveals the drive chain assembly. Covered in mud and completely devoid of lubricating oil, the footage unexpectedly intercuts with a night festival scene. Brilliant lantern light along with traditional dances. The rhythmic dance steps of the umbrella holding young women create a completely contrasting rhythm with the rough mechanical aesthetic. The sound of the bamboo flute plays passionately, carrying a deep resonance of Highland folk culture, incredibly serene. Returning to the makeshift repair site. On the dirt road, the mechanic remains patiently committed to the maintenance work. The appearance of passers-by does not interrupt her intense concentration. The disassembly process continues to unfold. The specialized toolbox is opened once again. The technician meticulously selects appropriate sockets for the chain guard bolts, setting up the electric impact wrench and reversing the switch. Using the magnetic motor to remove the rear swing arm cover bolts. Maximum torque breaks the bond of the rust. The painted guard bolts are easily removed. Temperature. Operations are carried out extremely professionally and skillfully. Handheld power tools significantly increase efficiency, pulling the lower half of the chain guard straight out, revealing accumulated dirt, rocks, and iron filings. Putting on medical rubber gloves. Ensuring chemical safety before coming into direct contact with the waste oil mixture, lifting off the remaining upper guard. At this point, the entire chain and sprockets are fully exposed. Pulling to test the chain's slack. The level of mechanical wear shows that this drivetrain has reached the end of its lifespan. The chain S are completely seized due to prolonged dry friction. Pulling forces permanently stretch the pin system, deciding to completely remove the chain for detailed inspection. Spinning the wheel by hand to find the master. Accurately locating the master, which is the only designed with a U-clip for removal. Using specialized needle nose pliers. Placing the plier tips on both ends of the clip and applying compressive force to pry the locking pin out. A decisive squeeze releases the safety clip, popping it out of the locking groove on the chain roller pin, removing the clip plate to reveal the two load-bearing steel pins. The removal requires finesse to avoid bending the pins and the sprocket. Later reveals signs of severe wear on the tooth tips. The sprocket can no longer grip the chain rollers. Taking a specialized chain breaker tool from the toolbox, preparing to remove damaged chain S if necessary. This tool uses a mechanical screw thread to press the pin, to push the riveted pin out of the side plate, extremely safely. Attaching a hex socket to the cordless impact wrench, to combine its power with the specialized chain breaker, clamping the breaker body firmly onto the exact chain position. This mechanism ensures the pressing force is perfectly coaxial. Pulling the electric wrench trigger, the RPM generates torque, acting on the threaded shaft to push the riveted pin out. A close-up shot shows the steel chain pin being completely pressed out of the metal side plate. Reversing the cordless wrench to retract the breaker pin. The chain has been perfectly separated. Removing the breaker, the technician picks up the broken pin, carefully observing the wear level of this component. After replacing or fixing the damaged chain section, she proceeds to reconnect both ends of the drive chain, installing the safety clip securely into the chain groove, ensuring the master is firmly secured, standing up and pressing the tire with a foot to check for play, to assess the actual load on the drivetrain, using a soft woven cloth to wrap around the drive chain. rotating the wheel steadily with the left hand to clean off dirt. The continuous wiping action under light pressure helps completely remove iron filings stuck on the rollers. The rear wheel rotation starts to become noticeably smoother. Proving that minimizing the grinding friction was effective, the technician visually inspects every single chain to detect any mechanical binding points. The process of cleaning the metal surface is crucial. Before applying a layer of specialized lubricating grease, spraying a suitable amount of foam-type chain maintenance fluid directly onto the gaps between the side plates and rollers. The fluid penetrates deeply into the load-bearing pins, creating a lubricating film to prevent metal oxidation. After completing the lubrication for the entire chain cycle, she starts packing her tools away into the toolbox, moving on to the reassembly stage of the protection system. Picking up the lower half of the chain guard, installing the lower guard onto the motorcycle's rear swing arm, precisely aligning the positioning bolt holes, continuing to assemble the upper guard cover. The internal U-shaped joint between the two halves must fit perfectly, fully enclosing the sprocket and chain drivetrain system. Prevents mud from splashing back and causing wear on the engine case. Preparing the socket and cordless impact wrench, again, ready to permanently secure the mechanical connections. Fastening the chain guard bolts with just enough torque to avoid cracking the plastic walls or stripping the metal swing arm threads. Securing the remaining bolt positions. Test spinning the wheel. There is no scraping sound. All technical parameters have reached optimal states. The mechanical device is now operating smoothly and quietly, smiling and giving a thumbs up to signal success. The drivetrain maintenance session is successfully completed. Taking back the clean cloth, she continues to wipe the exterior of the chain guard to ensure a clean appearance, wiping away excess grease splashed onto the shock absorber, keeping the metal surface free from dirt and grime. Still not completely satisfied with the machine's tightening force, she uses a cordless impact wrench to double check the bolts, tightening the swing arm cover bolts one more time with the power tool to ensure the bolt's elastic limits are properly engaged. The low camera angle highlights the mechanic's meticulousness, as she doesn't miss a single small mounting bolt. Moving on to the rear wheel axle area, she hand tightens the nut on the drum brake rod to adjust the free play of the rear brake pedal. This ensures the brake shoes expand evenly and grip the hub properly. She constantly checks the tension of the brake lever, setting up the ideal clearance to guarantee the safest braking performance. Next, she turns the chain adjuster nut at the end of the aluminum swing arm, synchronizing the chain slack on both the left and right sides. Proper chain tension is crucial for smooth acceleration. This final fine-tuning step for the drivetrain wraps up the professional technical workflow. She begins sorting and putting her tools back into the toolbox. The deserted scenery envelops the dirt trail. The motorcycle has had its full practical functionality restored. The mechanic gets on the bike and gently starts the engine, then goes for a test ride right on the mountainous terrain. The bike moves steadily with a smooth-sounding engine, proving her excellent maintenance and repair skills. The frame cuts back to the empty dirt patch along the forest road. The process of cleaning up the workspace is taken very seriously. She takes off the rubber gloves covered in grease, gathers all the scrap materials and wrenches into a plastic bag, and closes the plastic case lid, securely locking the latches, completely finishing the series of outdoor machinery restoration tasks.